Hi everyone, welcome to day 10. Your homework for today is the activity that we're going to be doing in class. If you don't happen to finish it in class, then you'll just have to finish that. Traditionally, the majority of people finish all of it or maybe are only one or two questions short. And if you could have your homework out from yesterday on independence. A reminder of our independence formula. Now, make sure we want to have this written with our OR formula on the front of our packet. So on the very front of the packet, we want to make sure along with the OR formula we have independence is probability of A times probability of B equals probability of A and B. This formula along with the OR formula are the two that you will need to have memorized for the test. So in this first one here, they told us they were independent. So that means we know this formula is to be true. They gave us the probability of A. We didn't know probability of B, but we know the and. So you can leave it as probability of B, or some people like to put an X in there. We'll just divide the 0.75 over. And that would give you 0.2 then for the probability of B. So on the next one, we want to know if left-handed and brown-eyed are independent. So we are given our probability of brown-eyed, they're given our probability of left-handed, but they don't give us brown-eyed and left-handed, they gave us brown-eyed or left-handed. So anytime you are given an OR in a problem, you have to use the OR formula. So that's what I'm showing here. I have my OR, 0.52, is equal to the probability of brown eyes plus the probability of left-handed minus the probability of both, which we don't know. So anytime there's an OR in a problem, whether you're asking for it or it's given to you, you need to use the OR formula. So you can just think of that spot as an X. So really, if we add those together, we would have 0.54 minus X equals 0.52. You can subtract the 0.54 over to give you that negative X is equal to negative 0.02. And then divide the X over to get that X is 0.02. And that's where this is coming from here. Well, now you can do probability of brown eyes times probability of left-handed. Is it equal to both of them? We don't know, so we have that question mark. Multiply out the right side, we get that they're not the same. So you can either say not independent or you could say dependent. But a big thing in this one here, and I know it'll come up several times on the test, is anytime you see that OR, you automatically need to do the OR formula. And whichever thing of the four you don't know, just put an X in that spot. We got a two-way table at number 3. They gave us all the totals. So probability of high school graduate. The spot that is only representing high school graduate is the 310 out of 500. Probability of owning a home is 340 out of the 500. And then the and is just where those two rows and columns cross. So you got 221 out of 500. So the individual probabilities multiplied, we don't know. Is it equal to the and? You always want to type in both sides because sometimes they'll reduce. In this case, our right-hand side didn't reduce. They weren't the same, so we say not independent or dependent. In years past, I've seen people have only this row on their tests and then write not independent. Well, you can't make that in conclusion until you punch them in. So you need to actually show this on your paper that they're not equal, the two fractions, if you're going to say they're not independent, or you can say dependent. Either of those is fine. Going over to 4, we need to do the Venn diagram, and you always want to start with the middle in the Venn diagram. If you don't know the middle, there should be enough information to figure it out. And here, they gave us the dogs is 39, the cats is 34, and 60% own a dog or a cat. So when we see dog or cat, we immediately want to go to that OR formula. So here's that OR formula. We've got the OR is 0.60, the dog, the cat, and then minus the and, which you can think of as X. When you go through and solve that, you get 0.13 for the middle. Well, then remember, the entire cat circle has to add up to 34%. We already used 13% of it in the middle, so that means there's 21% left for the cats only. The entire dog circle has to add up to 30, what do we have for dogs? 39% for dogs. We already used 13% of it in the middle, so 26% for the dogs only. And then your leftover is what goes outside, so we had 40%. Well, now in B, we have everything we need. Dog only was 39, cat only was 34, both was 13. Type in the left, they're not the same, so you can either say not independent or dependent. So on this one, people sometimes get confused and say, well, where's the red, where's the green? Well, in each combo there, one of them came from the first die, one came from the second. So as it says there in the list, you can consider the first die the red and the second die the green. So we want sum is 7. So the ones that are 7 are all of these ones. So that gives us 6 out of 36. So that's this here, or you can reduce it to 1/6. Then green die shows a 4. Well, I let the second one be the green die. That's these. That's 6 out of 36. And then the ones that are in both are just 1 out of 36. So when we do our independence formula, the individual ones multiplied does equal the and, so this one is independent. You will definitely see at least one question on your test where it asks you to do this independence formula. You'll find your individual probabilities and see if when they multiply they equal the and. So hopefully by now you have your Titanic activity. We will be using the tables on the front to do the each of the problems. Now, I can't remember if I did it this year, but most years I have the back side of this blank. So look in the packet. If the back side of this is blank, the intent is then you can rip that front page off so you won't have to flip back and forth to look at the tables. Hopefully I was smart enough and did the copies that way this year as well. So April 15th, 1912, you probably know the story. Titanic hits an iceberg, it sank, and a large number of the people on it did not end up surviving. And this is the breakdown of the people that survived or didn't survive, broken down by class and broken down by class, as well as being children, women, and men. So we're going to investigate a few things using probabilities with this today. We will need our calculators out, so if you could please have those out and ready to go. And once you have your calculators out, if you could go ahead and read all the way through question 1A there. So since independence, our formula, it's still somewhat new. We just saw it for the first time yesterday. We're going to practice these ones together. So what we're looking for when we see independent, we want that formula to pop in our head. So what we're going to look for here is probability survived times probability of first class. Is it equal to, we don't know, the probability of survived and first class? And that's what we want to try and determine. So looking at the chart, we want to find a box that the only thing it represents is survived. And that would be this 500 here. So we're going to have 500 over our overall total. Remember, ands, ors, and individual probabilities are always out of the overall total. Well, in your independence formula, the left two things will always be individual probabilities, and the right will be an and. So everything in your independence formula should always be out of the overall total. So now probability of being in first class, the box that would represent that would be the 324. So you got 324 over 1317. We want to know, is that equal to the intersection of them, the ones that are both those things at the same time? So we want to see where does first class and survived intersect. That's at the 201, so that's 201 out of 1317. So we want to punch these in, and we should punch in both sides because sometimes they will reduce. If we multiply out the left, we get 18,000 over 192721. And on the right, this reduces to 67 over 439. Those are not equal, so we can either say either not independent or dependent, either one. Well, now we're going to look at survived and third class. So there's going to be a lot of similarities. We'll start out with the probability of survived, which again from above was 500 over 1317. But now we want to do a probability of third class. So if we look at the total for the third class, that was 709 out of 1317. And we want to know, is that equal to the and? So the ones that are both of those at the same time. So see where survived and third class intersect. That's 181 out of our total of 1317. Well, we'd want to punch in both sides to see if they're equal. We would find that the right side does not reduce, and the left side we get a pretty big fraction here, so it's clearly not equal. Actually, I think this maybe was a 9 on the end. So those are not equal, so we could say dependent. So if things are independent, knowing one does not influence the probability of the other. But if these are both dependent, what this tells us is knowing the class influences the chance of survival. It doesn't necessarily prove how it influences it, but it just tells us because they weren't equal, knowing one of them changes the probability of the other. All right, take a moment, read through all the way down to question 2A. So for the rest of these, we're going to look at conditional probabilities. So this notation that we have with the vertical line, remember the thing after the vertical line is what is given, and then that tells you the row or column to focus on. And then looking only at that row or column, then we would find the probability of the other thing they want. Now all the rest of the questions here are going to have us round to the nearest 1/10 of a percent. So we'll divide whatever fraction we get, move the decimal over 2 spots, and then round to the nearest 1/10. So a recap of how to do this, because it's been a couple days. So given, we want to find the probability of passengers survive given they were in first class. So we're going to focus only on the first class row because that's what was given. So now only out of that row, we want the probability the passenger survived, which would have been 201 out of the 324. We would divide that in our calculator. We would get 0.6203 and other stuff. When we move that over 2, we'd get 62.03 and some other stuff percent. So that would be 62.0%. We're going to pause the video for about 3 minutes. No, we'll do 4 minutes actually. Pause the video for 4 minutes. See if you can do 2B, 2C, and 3. See if you can do all 3 of those. All right, so in 2B, we're focusing only on those given second class. Probability that we survive should have been 118 out of 284. And eventually you should have gotten that was 41.5% after you divided, moved the decimal over, and rounded to the tenths. For 2C, focusing only on the third class passengers, we should have had 181 out of 709. Divide that, move the decimal over 2, round to the nearest percent, and you should have got 25.5%. So what is this? What should we conclude? Hopefully you came up with something along the lines of the lower the class, the less likely, or the lower the chance of survival, we'll say. And you could have said that in reverse as well. You could have said the higher the class, the higher the chance of survival. But hopefully we recognized that analysis from our results. All right, moving over to question 4, we're now going to break it down into not just the classes, but children, women, and men. So the first one, and then the reason we're looking at this is the policy of women and children getting first dibs on the lifeboats, essentially. So we want to find probability of passengers survive given the passenger was a child. So we want to focus on only the children. Well, the problem is the children are split up into 3 spots. We have the first, second, and third class children. So what we're going to have to do is we're going to have to look at how many survived out of all 3 of those, out of how many total for all 3 of those. So our survivors are 4, 22, and 30. So we'd want to add up the 4, the 22, and the 30, and that will give us 56. So that's going to be our numerator. Maybe I'll write it over here. And then for our totals, we'll have to look at all 3 of the totals added up. So the 5, the 22, and the 80, we'll add those up. Which will give us 107. So we got 56 over 107. And eventually that would give us 52.3% when we divide, move it over 2, and round. Let's look at one more of those together, and then we'll let you try the third one, because this can be a little tricky because we got the 3 different groupings to look at. So we want probability of survival given the passenger was a woman. So we want to look at only the women rows. We would have to add up our survivors, the 139, the 83, and the 91. If we added those up, we would have gotten 313. Over our total, so we want to add up the 143, the 95, and the 179. If we add those up, we get 417. And if we divide that, move the decimal over 2 and round to the nearest tenth, we would get 75.1%. So we're going to pause the video for 3 minutes for you to do part C and then question 5 as well. So for part C, we should have gotten 131 over 793, which in the end would have given us 16.5% when you're rounding. And your conclusion, hopefully you found something like women and children were the most likely to survive. Or you could say men were the least likely to survive. That would be okay as well. All right, moving over to question 6. We're going to do part A together, and then we'll end the video, and it'll be up to you to finish the rest of the packet. You might be able to do that in class, or if not, finish whatever's left at the end of the period for homework. So we've got the probability that a child survived given the child was in first class. So that means, because the child in first class was given, we want to focus only on the children in first class. Using only the things from that row, what's the probability the child survived? That was 4 out of 5. Well, we want to round all answers to nearest tenth of a percent again. That would give us 0.8. So if we move it over twice to the nearest tenth of a percent, that would be 80.0%. So we'll leave the rest of them for you to do, and then we'll go over those at the start of class tomorrow. Don't forget, I think it goes on to the next page possibly, but don't forget to do number 7, your final conclusions based on everything. So what we're looking for that is, all right, if we looked at all these probabilities we did, what can you say about class, men versus women versus children, things like that. So finish that up for homework and in class, and have a great rest of your day.